Okay, so this example is much shorter than the previous one, and actually this should come earlier. I don't know why I pushed it to the back. So what we need to do here is just specify the required length of the number 60 chain to mount a sprocket on sprocket that having 15 and 50 teeth with the center distance more than 419 millimeters, and compute the actual center distance. So that's just application of the equation, because now we know the type of the chain. We only get to not need to find the pitch value for that chain, and then we're going to calculate the C value for the whole thing. So we have been given actually the type of the chain, we've been given the teeth numbers, and we've been given the center distance to be within that range. Okay, so we're going to do that first. We're going to table 713, and we will find that the for the number 60 chain, the pitch value is 1905. You remember that. Okay, so we are going to calculate the C value. Now we said that the length should be within 900. So if I would like to know what the number or the pitches, I will do the opposite thing. So mainly is going to be the 900 divided by 1905, and I will get it to be equal to 47.244, or what's equal to 48 pitches. Now I'm going to check for the chain length, okay, by using the equation for the L, and we're going to choose what we have earlier, 48 pitches for the C. Remember that it's within the range, because we said there's going to be anything between 30 to 50. So the 48 is less than 50, so it's within the range. And we know the number of the teeth for both sprockets. I'm going to put that in the equation, and I will come out with the L value to be equal to 129.19 pitches. So definitely I can choose the L to be 129 and continue with the calculation. And now we're going to choose the equation 720. We have the L, we have the N values, and then we can recalculate the C. So put everything in the equation. Well, actually, if I was him, I would use 129 instead of 129.1. Anyways, they're going to get the value to be equal to 47.98, which is same thing. 47.98 is equal to 48 pitches. So this should be okay. Okay, and that's mean that the value for the C is going to be 913, which is less than 914.4. So again, that I think that the value of that's going to be dropped to 129 is going to make a little bit difference in the terms of the millimeters. You can check that yourself and tell me if we actually can simply use the even number of 128, which is for the L value to be much less than the 914. Now, the other example we're going to have here is going to be the chain drive. Just remember something. I'm going to cover the 2 and 3 in the class before the other one. So we need to remind the power rating of the number 60 chain, single strand, operating at 22 sprocket at 750 RPM. We need to describe the preferred method of the lubrication. The chain connects a hydraulic drive with a meter grinder. Okay, so hydraulic drive with meter grinder. So now you know the combination. You can tell it's going to be the first column with the first row. What will be the rating for the 3 strands? Okay. Now we come to the table for the chain 60, and you remember that we said that the RPM is given to be 700, and the power rating can be now found because we know the number of the teeth, we know the number of the RPM, and again to get the value of the power between 17.51 and 23.08. Now we need to do an actual interpolation here. So we are going to know definitely that this will be the pitch value, it's 0.75, and that's the type, which is the type B, and I can tell what the type of the lubrication we can have for it. So we know everything now. By the interpolation, we'll get that the power should be in the range of 21.7 horsepower. Now we're going to calculate the service factor. So we go to the 717. We said hydroelectric drive. We have the meat grinder. So let's see where's the meat grinder. Yeah, food mixers and grinders. So we're going to get the value for the S, which is going to be equal to 1.2. We have the power as 21.7. So I can find the actual power for the motor to be equal to the service power divided by 1.2. And thus it's going to be 18.75 horsepower. So for the three strand, the factor is going to be 2.5. So the power rating now is going to be equal to the 2.5 multiplied by 18.75. Okay, now if that confuses you, let me tell you the following. That's the power we got for the one strand. And that's the actual power because that's what's the design power. Now, if I can use three strands, that's mean the load has been divided by 2.5. So to get the actual load or the actual power, I need to multiply it by this factor, not divide as we did earlier. So the actual horsepower was 45.19. Okay, so that's it. Thank you very much, and we'll get to meet later for another.